After them. Our question today is the question from MIT integration, MIT integration, PEA 2020 problem 1. Beautiful. So this is our question for today. Right. This is integration. All right. This our integration in question is integral natural log of 2x all over x natural log of x dx, and this is the MIT question. Yeah, that the student were expected to solve. So with this integral, as I said earlier, every integration is different. Okay, but with me, if I'm solving this question, first I will look at the top and down, and when by so doing, I can see the technique or the way to break it down. So this, if I say the integral of natural log of 2x all over x natural log of 2 dx, can be written as natural log of 2 plus natural log of x all over x natural log of 2 dx. So all what we have done is we've expanded the integration. So then I say by separation, okay, if I separate them, then my integration is going to be natural log of 2 all over x natural log of, this is x, isn't it? This x, okay. So natural log of x, so that will go stay on its own, and I'll say this one is also natural log of x integral, the same denominator stays, dx. So this has made things easier now. So if that is the case, let's say this one is A, and this one is A, and this is B. Okay, so we have been able to break the integration into two. Okay, when we observe the integration very well, we can see that we have the same denominator. So these are the denominators are the same. Okay, because we have expanded and split it into two. Okay, so if we look at it very carefully, we see that the natural log of s here will cancel this one down here. So then we'll be left with our integration 1 over x dx to resolve for the b. So what about the a? Okay, then the a is such a way that we have to break it down further. So if we separate it, if this is our a, which is natural log of 2 all over x natural log of x dx, since we can integrate the b, this one, so easy, this one, let's do u substitution. So let's say u is equals to natural log of x. So then when we differentiate, we get du is equals to 1 over x dx. So this implies our dx is equals to x du. So this what happens to break it down and integrate this ones. Okay, now since we know the respective integral, we'll say that this integral, let me take the white one. Okay. Okay. So the integral natural log of 2 all over x natural log of x dx now can be written as, we can bring the natural log of 2, which is a, since natural log of 2 is a constant, we can bring it out and say natural log of 2, okay, dot integral 1 over x, okay, but we have natural log of 2, okay, out. Then we have natural log of x, which we know that is equal to u. So we put u here, okay. Then our dx, now we know our dx is x du. Then straightforward, we can say that we can cancel x and x. So then we'll be left with the natural log of 2 integral 1 over u du. Wow. So you see that it's now so easy for us to integrate. Okay, now let us reflect. We realize that we have to do separation, and after that we decided to call the left one A and the right one B. So now let's put all the breakdown together. When we do that, then we still have natural log of 2 integral 1 over u du plus integral 1 over x dx. Okay, so now we are in a good position to be able to integrate this with ease, because we know that when we integrate 1 over x, we have natural log of x. This one will be natural log of x, and when we integrate u, will be natural log of u. So let's do that. So we have natural log of 2, okay, then we say natural log of u plus natural log of absolute value of x plus c. Beautiful. Well, what do we see? What do we see here? So this is the final answer, but it is not a final answer. It is not a final answer. Why? Because we have natural log of 2, natural log of u, and we have absolute value plus, we have plus natural log of absolute value of x plus c. But our problem now is the u that has found itself within our integrand. So what do? We have to find something to replace the u. But we shouldn't forget that we said over here that let u to be equals to natural log of x. So then we'll put u to be natural log of x into our answer. Okay, so now this is going to be natural log of 2 into bracket natural log of x, yeah, plus a natural log of absolute value of x plus c. So this is the answer. Okay, it looks so beautiful. It looks very long, but it's nothing to be afraid of. It's all about being able to know what you are doing. So natural log of 2 into bracket natural log of x plus natural log of absolute value of x plus c. So this is the MIT question that we saw. It looks very complicated, but it's not anything that we cannot handle. Beautiful. So let's recap and see what we did. So right from the top, we know this is the integration given. Okay, so then we separated the integration. So we know that here we have 2x over here, and it's the natural log of 2x. When we apply the properties of logarithm, this will be natural log of 2 plus natural log of x, all over the denominator. Okay, then after here, we decided to break it down further. Okay, so when we did that, then we had natural log of 2. Okay, as you can see, natural log of 2, but the denominator. Okay, and this one, natural log of x, but the denominator. So then we got to this point here. Okay, then after further observation, we realized that the length of x will cancel each other. So we decided to name the right one B and the left one to be A. So after cancellation, we saw that natural 1 over x ds is easy to integrate. So we put it aside. Then our concentration was now on the left one, which is the first one. So that we all know is natural log of 2 over x, natural log of x. Then we substituted u to be equals to the natural log of x over here. Then after differentiation, our the x value was x du. So we substituted this ones is, you see in blue, into the equation, and we have natural log of 2 times the integral of 1 over x times x du. And after further cancellation, we got to natural log of 2 integral 1 over u du. And that, we decided to put them together here. So we put them together here. Put them together. So then we know the first one is natural log of 2 integral 1 over u du, and the other one is integral 1 over x dx. But we all know that when we integrate 1 over u, we get natural log of u, that is over here. Then when we integrate 1 over x, we have natural log of absolute value of x plus c. But after doing that, we realize that the natural log of u shouldn't be part of the equation because the original equation didn't have anything like u. So we remembered that initially we said u is supposed to be equal to natural log of x. So then we came back here and substituted the natural log of x in its place, and that gave us what we have here today. So this finally is the answer to this question. You see. Well, thank you very much for coming around and enjoying the class. But I will be excited if you will subscribe and also like the videos that we're doing. You can also share it to your friend. This one, we don't have any copyright, to impose. We don't impose any copyright on anybody. Just share it with your friends who also want to learn. Yeah? Thank you very much once again, and see you again. Thanks.